measuring the electricity used, charging the customer, paying the bill. There was no such thing in 2001 in Bangalore, and most of the parking lots they didn't had a plug point. So these Reva car owners, whoever purchased, were facing difficulty to charge while they were parking it in basements of malls or cinema theaters or public parking spaces. So Reva car owners stopped spreading the good message. Reva car was beautiful. It was value for money. It was able to give very good mileage. It's very comfortable. Okay, so I hope you understand the Reva car owners were not giving good feedback because they don't have had the uh, luxury of charging it at parking places. So they gave a negative feedback loop. So they, since Reva car sales started falling, so people were not installing plug points in charging plug points and charging stations in parking lots and apartment basements. Okay, so I hope you understand. Though sales initially grew, there were not enough cars in operation for charging infrastructure to be sustained. Reva cars were sold in very good number in 2001, but sustainability, the same number of cars must be sold every year at least to keep the industry alive. So Reva cars network was not expanded. Say for example, I am from Nellore and I work in Gudur, which is 40 kilometers. Reva car is exactly suitable. I was eager to buy Reva car since 2001, but they never expanded their distribution network. They never opened new showrooms. They never increased the capacity of manufacturing capacity because there was negative feedback loop by the owners who already purchased and operating the Reva car. They were always complaining about charging infrastructure. They were always complaining about the range limitation. They cannot go beyond 40 kilometers out of the city. They have to travel 20 kilometers and come back home 20 kilometers. So this feedback loop, so you may think that India EV revolution has started. It already started in 2001, but it is suppressed and it is in sublime condition since 2001 because of negative feedback loop by all the stakeholders. The manufacturer always say that sales are not good. The buyer always says that there is no charging infrastructure. The parking owner, the cinema hall owner, the mall owner always says that only one or two electric cars are coming. Why I have to install charging points for them? So this is, and the distribution dealer network. I am selling only one car or two cars per month. So why you should start a very big showroom and pay rents? So this is the negative loop that is killing the electric vehicle industry. And also government hand is there in this, so I'll show you that. So next is what in 5 W's and 1 H. Next is what we have seen: when, where, why, when, what, why. So let's see what if condition, the same what once again, because you must know uh, the importance of changing the thought process, changing the psychology, changing the mood, setting the pace. So, what if there are more charging stations? So, we must ask questions to ourselves to find answers. Being an engineer, we must question ourselves and find answers. What if there were more charging stations? So obviously, more buyers will come forward to buy cars. So automatically, a positive feedback loop will start and sales will increase. What if there were options to swap battery at regular intervals of 200 kilometers in entire country? So obviously, I'll not have fear of charging, wasting 90 minutes of my time to charge the battery. I can swap my discharged battery with a fully charged battery. So obviously, the customer confidence will increase. So I hope you understand uh, the importance of questioning ourselves to find solutions. What if the old EV scrappage and battery recycle facilities are rewarded? Now, uh, whoever have purchased electric scooters, they have to change the battery for 3 years. Old battery, new battery, the cost difference is somewhere around old battery gets you 800 rupees, new battery is 13,000 to 14,000 rupees for scooters, normal basic scooters, entry level scooters. I hope you understand the price difference. old battery is 800 rupees, new battery is 13,000 rupees. So that is huge change. The material is same, the only thing is manufacturing process is different. The scrappage scrappage policy, the reward is very very less. If you are giving back your battery and getting a new battery from the same company, there must be some kind of reward, there must be some kind of benefit added, value added service to be offered to the customer. So now there is huge difference. I'm giving my old battery but getting new battery at a very high price. So I hope in future, if this price difference is adjusted or made brought to some kind of equilibrium, more people will come forward to buy electric vehicle, and more people will be happy to change their batteries after 3 years instead of throwing away their electric vehicles. So what if we all switch to electric cars? How much percentage of electricity demand increases? We are all electrical engineers. I was able to see your roll number, some of your roll numbers 209 and 212. So all are electrical engineering students. Some of us will definitely have doubt. So if we switch from petrol cars, diesel cars to electric cars, so what will happen to electrical demand? So the survey is already done. There will be only, if the entire world shifts from petrol diesel cars to electric cars, there will be only 25% increase in electricity consumption. So there is no need, no harm, no worry about increase in electric demand. So we can switch from petrol diesel cars to electrical cars. There will not be any uh, stress or strain on existing electrical transmission, distribution, generation networks. Okay, so I hope you got into track with what I am trying to convey. So now next, five wives one husband, 5W1H. Next one is where. Next W is where. India has 82.8% import dependency on crude oil. Hmm. Hmm. వచ్చారా 4:30 అజెండా మీటింగ్ అజెండా. ఏపీపీ పాయింట్స్ ఇచ్చేసారు కదా రిజల్ట్ లో వచ్చేటప్పుడు. ఉన్నాయి. Sorry for interruption. Now we must focus on where is the hope. So I have told you that EVs are 200 years old, that there is a negative loop since 2001. The sales did not increase. Are you able to follow my lecture? Do you need more emphasis? Even though I'm an electrical engineer, I'll stress more on business aspects rather than engineering and technological aspects, because our lecture focus is on startup opportunities in EVs. So my focus will be mostly on financial, managing the resources, managing the production capacity, utilizing the production capacity. Okay, so India has 82.8% import dependency on crude oil. So whatever petrol and diesel we are using, all this petrol and diesel is coming from crude oil, and India doesn't have crude oil reserves, so we are importing that. So 82.8% oil is coming to India from foreign countries, and the total imports done by India, 32% is fuel. So I hope you understand how dependent we are on fuel imports, and all those imports we have to pay the seller with petrodollars. So only US dollars is accepted. So now in 2020, 2020, 2021, 2022, because of COVID or because of war in between European countries, there is huge uh, increase in price of crude oil, or huge uh, uh, gap in demand and supply. So government is facing heat. So this is where we have hope. Government is unable to pay importers with dollars. Government is unable to show import export balance, because we are importing more and exporting less. So they are unable to show the balance, and we're more dependent on foreign countries. So government has taken some initiatives like Atmanirbhar Bharat. Atmanirbhar Bharat means self-sustaining, self uh, resources, you generating the resources locally and utilizing them locally. So this is what is all about Atmanirbhar Bharat. So to make India sustain, we have to reduce the oil imports. So the only customers who need this fuel is cars and bikes. So if we can switch from petrol diesel vehicles to electric vehicles, automatically India becomes self-reliant. We don't need to pay them in dollars. So automatically our exports will be more than imports if we can minimize the crude oil, because it is 32% share. So if you can minimize even by 10%, crude oil import is minimized by 10%, there will be huge difference. We can have more foreign reserves. We can do much better things for the country and nation. So this is where hope is. This is where people think that EVs are the future. EVs will be sold in large numbers in coming years. Okay. So now let's see how. I told you 5Ws and 1H. So where is hope? I have shown you the gap. So how we are going to do this? So this is always question for engineers. We engineers, we search, we do survey, we find out answers. So I did it for you. So how you can say that it is hope? I told you where is the hope. This is how I would like to justify it. So government gets revenue by taxing. Say for example, these are the petrol prices, February month petrol and diesel prices, electricity prices in Delhi. Okay, petrol price is around 111 rupees in Delhi in February. Okay, because I got this data from newspaper, and that's an old data. I was unable to get the latest data. So students, can somebody unmute and unmute yourself and tell, are you able to follow the lecture? Is my lecture interesting?
Yes, sir.
Sir,
Sir.
yes, sir.
So shall I go ahead?
Yes, sir.
Okay,
Yes,
okay,
sir.
very good. Very nice. Because I feel that I am talking to my laptop rather than talking to classroom. It is very difficult to take virtual lectures because I don't see you. I'm able to see only my laptop. So if I see your faces, I can understand whether you are, I can observe whether you are interested or not, because I am unable to see your faces. So I got a doubt. So now let's get back. In petrol price is 111 rupees. Government gets somewhere around 47 rupees or 46 rupees as tax. So in similar manner, diesel is sold at around 99 rupees or so. Government gets a tax of somewhere around 38 rupees. Okay, and electricity is commercial electricity unit is BOT. We generally call 1 kWh as 1 BOT, Board of Trade unit. In short, we call it as 1 unit. 1 unit of electricity is somewhere around 11 rupees. Depends upon state to state. 9 rupees to 11 rupees commercial. So government gets a tax of around 1 rupee 10 paise or so. Okay, electricity cost includes duty, tax, cess, surcharge. You can see the difference, how much government is earning. Okay, so if you see, no government, traditional conservative government, no government will say we will reduce petrol and diesel sale, because government gets lot of taxes. Government runs only by collecting taxes. These taxes are given back as roads, infrastructure, electricity, water, hospitals, education, all these things comes from tax. And even the popularitarian schemes like free education, free ration, free healthcare for bpl families, below poverty line families, free housing for below poverty line. So I hope you all know white ration card people holder get a lot of benefits from government. All those money is coming from these taxes. No government, traditional government will say we will switch to electric cars, because if you sell electricity, government gets only 1 rupee 10 paise. If you sell diesel, government will get 38 rupees. If you sell petrol, government will get somewhere around 46 rupees. I hope as audience you can see government will always encourage petrol and diesel cars, because if you fill petrol, 50%, close to 50% of the amount goes to government. If you use electricity, only 10% of the amount goes to government. So most of the governments, they enjoy these taxes, they collect these taxes and give it back in terms of infrastructure or in terms of schemes, okay, or flyovers or airports, whatever it is. So this is how government gets revenue by taxing. But this tax money is going to petrodollars. This tax money, earlier this tax is enjoyed by the government. Now India is not having oil, so all that money has to be sent back to the exporting country. Say for example, we are importing crude oil from Saudi Arabia. That money has to be paid to Saudi Arabia as dollars. So if you convert rupee to dollars, so automatically all this money is sent back. So government is not getting any benefit by taxing the people. So now government is switching to selling electricity. So even if they get 1 rupee 10 pice, 1 rupee 10 pice will be with Indian government. Even if you get 48 rupees tax from petrol, all that money goes to foreign countries, because it is not our resource. We are importing it. So I hope you understand why government is encouraging electric vehicles now. Earlier there was no such encouragement. Now there is encouragement. Next, dealer commission. I think you know petrol pumps are run by private companies. Even you or me, we can start our own petrol pump on any roadside. Okay, if you have a plot, you can apply and you can start petrol pump. So what the dealer gets? Okay, dealer gets 3 rupees 80 paise for selling 1 liter petrol. Dealer gets 2 rupees 60 paise for selling 1 liter diesel. If the dealer starts a electric charging station for electric vehicle, he is going to get 3 rupees 50 paise. This is the present electric charging station franchise model. So dealer is not going to get affected. Government is going to get heavily affected, but dealer, whoever sells petrol or diesel, if he converts his petrol pump into electric charging station, he is not going to get affected. If he sells 100 liters petrol, he will get 46 rupees. If he sells 100 units, he'll get 350 rupees. There is no much change. Okay, dealers are ready to switch from petrol pumps or diesel pumps to electric charging stations, provided there are sufficient number of electric vehicles. So from dealer point of view, there is hope. Okay, so dealers want to switch from petrol pumps to electric chargers, because there is no, the margin is not getting affected. But why customer is not shifting from petrol cars to electric cars? That is the question already I have posted. When, why, all these things I have posted. So I hope you are getting clarity of all the stakeholders. I'm telling some of total fears. Why electric vehicles are not sold in large numbers like petrol cars and diesel cars? There are a lot of petrol and diesel cars, 140 crores. There are only 1.4 million electric vehicles. I'll show you some statistics, interesting statistics. As an engineer, we must read newspaper, we must listen to news, we must see business part of the newspaper, maybe in seventh or eighth page of newspaper. So now my question is, who is responsible for all these things? I told you when, what, why, how, all these things. Now the question is, who is responsible? Yes, automatically engineers and technocrats are responsible. All of you young engineering graduates, you are responsible for making EV successful. Okay, engineers and technocrats are responsible. So the EV revolution will require more engineers. So that is the reason why Naresh has arranged this seminar. So mm, I hope you understand why the seminar is organized, why your institution has an innovation incubation council, IIC. Because until and unless we don't come up with new ideas for old problems and new solution for existing problems, we cannot overcome this hurdle. The hurdle is there are less number of EVs, more number of IC engine vehicles. IC engine means internal combustion engine. So EV revolution will require more engineers. That is the first benefit. Uh, Next thing is electric vehicles are part of the fourth industrial revolution. If you would have studied your history, geography, economics, civics properly in 10th standard, you will know what is meant by industrial revolution. So now the world is going through fourth industrial revolution, and that industrial revolution is brought by electric vehicles and electric power industry. So if you go to your home, you will see only one form of energy, that is electrical energy. Your mixie is electrical energy, your grinder is electrical energy, your air conditioner is electrical energy, uses electrical energy, your refrigerator uses electrical energy, your light uses electrical energy, your fan is uses electrical energy, your cooking stove is electric, your bike is electric, your car is electric, your water pump is electric, your hair dryer is electric, your cell phone is charges from electric socket, your TV is electric, your microwave oven is electric. The entire world, all houses are using only electricity. So this is the cause of fourth industrial revolution. So the only two two things that are still using traditional fuels are cooking. LPG is used for cooking, that is replaced by electricity. The only thing that is using traditional fuel is cars and bikes, that is replaced by electricity. So this is the fourth industrial revolution, and we have to support fourth industrial revolution and make it a big success. That is in the hands of engineers and technocrats. You're all future budding engineers, engineering aspirants. You want to become great engineers and earn decently well and get a good reputation in your society. So I want all of you to take it seriously and take up EV as a career path or career avenue. Okay. So this is driven by disruptive technologies. Disruptive technologies means you should not think traditional. You should think differently, and you should be come up with new ideas. Okay. So next thing is, compared to combustion engine vehicles, EVs necessitate more engineers. So, and more engineers in the sense, people from different disciplines has to form a team and they have to develop EVs. Okay. Earlier, automobile industry is dominated by mechanical engineers and automobile engineers. Now, EV industry needs mechanical engineers, electrical engineers, chemical engineers, software engineers, electronics engineers. So this is how a new ecosystem is evolving. Earlier, petrol cars, diesel cars needs only mechanical and automobile engineers, or maybe metallurgy and metallurgy guys are also needed. Now it's entirely different. For making an EV, you need electrical engineer, you need mechanical engineer, you need chemical engineer, because the battery is all about chemical reactions. And for optimizing battery, you need software, you need computer guys, you need electronics. The entire motor power, battery is controlled by power electronics. Power electronics is controlled by firing circuit, triggering circuit, sensors. So I hope you understand the fourth revolution needs a very big team of engineers, and all these engineers are from different disciplines. So I request you to, if you come to fourth year in 2024 or so, don't do project with same all five guys, electrical guys. Try to do project with one mechanical guy, one computer guy, one EC guy, one electrical guy, one IT guy or instrumentation guy. If you are able to do project in such fashion, you will become a successful engineer. If you do traditional project like 4 electrical engineers does a project, then it will be a disaster for from now onwards. Okay, earlier project was done by electrical engineers, project was done by mechanical engineers. Now that model that will not survive, will not sustain. Okay, so dear students, are you able to follow my lecture? Can somebody unmute and say yes or no? Can
Yes,
somebody
sir.
give
Yes,
me?
sir.
Is it interesting?
Yes, sir.
Do
Yes,
you
sir.
find
Hello.
it useful?
Yes,
Yes,
sir.
sir.
Very
Hello.
good, very good.
Hello, sir. Like,
Yeah,
I would like to ask a few questions.
yes,
Yeah, hi. I'm Gopichand. I'm not from this college. I'm from VNR VJIT, Hyderabad. So
okay,
my question is like, we have talked about EVs, battery EVs, but there was no discussion about fuel cells or alternative EVs. I mean, when you talk about in pure electrical analogy, there we need to think about in long run also. What about the lithium ion existence? I mean, it's rare metal, right? And what
yes,
about the grid stability? When we talk about fast charging, you need three phase or you need 100 like 30 kilowatt 40 kilowatt of fast chargers. And like what about the grid stability? And when we are looking about renewables, they are not stable. And how we would integrate all these solutions? Or battery EVs are sustainable in the long run, or is it better to shift for fuel cells? I mean, is it better to focus on fuel cells? Because at our college, like we are doing work in fuel cells. I mean, we are doing a project. I'm a student, a third year student from mechanical engineering. So we thought of working on hydrogen fuel cells. We are in the design phase for what if we are thinking, what if we power a motorcycle, I mean, with fuel cell. So is it okay to go with fuel cells, or just stop itself at batteries? That's my question.
yeah, Gopichand, good. I don't find this question offensive because it's a beginner's mistake or beginner's luck. We generally call both are same. In my point of view as an engineer, beginner's mistake or beginner's luck, both are same. If you don't know anything, if you start something, or you will always have fear of failure. I told you some of total fears. So I request you to go ahead with whatever belief system you have. Say for example, if you think fuel cells will succeed, go with it. If you think that electric batteries will succeed, go with it, because these two are two different aspects. Electrical batteries, regular batteries need to be charged. Fuel cell has to be replenished. These are two different streams. One is going towards east, the other is going towards west. These two roads will never join. It is an electric vehicle, there is no doubt, but the electric vehicle is powered by battery or fuel cell. Battery has to be recharged by a plug and power socket outlet. Fuel cell is replenished. Okay, you have to fill hydrogen fuel in the tank. Okay, these two are two different aspects. Please go ahead with your thought process. If you want to convert your bike into electric bike and that electric motor is powered by fuel cell, then please go ahead, because you have to fill the tank with hydrogen or whatever fuel, because most fuel cells are hydrogen fuel cells or some other fuel. Okay, if you want to fill the tank with fuel, please go ahead. That fuel is converted into electricity in the fuel cell, and that electricity is used by motor. This is the case B you are talking about. Case A is the battery is charged at home or at a highway charging station. The stored energy, electrical energy, is used by the motor. So you want three-stage conversion or two-stage conversion. It is up to you. It is up to the setup you have chosen. Both are electric vehicles. This is what we call as beginner's luck or beginner's mistake. Both are two different things. Okay, it is something like carrying instant noodles in your backpack or carrying a lunch box in your backpack. Okay, these two are meant for filling your stomach when you are hungry, when you are away from your home. The first one needs hot water to cook instant noodles. Okay, this the second one needs open the box, eat it. It's already cooked at home. Okay, so two different aspects for the same thing. I hope audience understood the Gopichand's question and my query. Gopichand, is it okay now?
Yeah, yes, sir.
Yeah, please go ahead
It's
with your plan. There is nothing wrong. You can choose fuel cell to power a motor, or you can choose a battery to power a motor. It depends upon availability of fuel for that fuel cell. Hydrogen is very volatile. If petrol needs fire, diesel needs fire and some kind of burning medium. That it needs a cloth or a piece of wood to catch fire. But hydrogen needs oxygen. As soon as it comes in contact with oxygen, it will explode. Even helium is same thing. They are highly unstable, volatile, and highly flammable. They don't need matchstick at all. They don't need spark. They don't need fire. They just explode immediately when they come into contact with atmospheric oxygen. That is the reason why fuel cells are considered dangerous, and it needs lot of people spend lot of money for the safety aspects. Please, both are reliable, both are future of uh, electric mobility. Okay, shall we go back to our presentation?
yes, sir.
Okay, so hope you're able to see the screen I am sharing. You're able to see the full screen I am sharing.
Yes, sir.
Okay, very good. So, my dear young engineers and future technocrats, I hope you understood why, when, where, how, where is the hope, all these things. You understand your role, your responsibility. Now, I hope you understand forming teams of different disciplines, why more engineers are needed. I'll show you a brief because it is very important, because you are all young, you have lot of doubts. So it is my duty and responsibility. I can just share uh, some 10 or 12 ideas about startups and I can close my presentation, but without understanding the basic fundamentals, you cannot identify the opportunities to start a business, to start up. So let's go through a brief presentation about entrepreneurship opportunities and startup opportunities. Okay, so before that, dear young engineers and technocrats, let's understand what is the automobile, how these automobiles are propelled using internal combustion engine by using an volatile fuel like petrol and diesel. I'll take you through this presentation very briefly because our focus is different, but you need information about petrol and diesel cars. Okay, so this. So this is an engine of petrol car. So it's a six-cylinder engine. You can see hundreds and thousands of parts are they have to be machined in a lathe by technicians. I told you we need more engineers. You can see compared to combustion engine vehicles, EV necessitate more engineers. Point 3 in this slide. Point 3. I told you EVs need more engineers. Okay, why more engineers are needed? Why regular petrol cars and diesel? In a regular petrol car and diesel car, an engineer designs the valves once. A technician, a diploma holder or ITI holder will make them using uh, a lathe in a workshop. Okay, so I hope you understand the difference between ITI, diploma, and engineers. So these parts are manufactured by ITI or diploma guys, but it is designed by engineer. If you design once, they have to be made multiple times for making number of cars. So this is a gearbox. Gearbox has hundreds of parts. This is a regular car gearbox. Okay, this is cooling system. The engine gets heated up because petrol or diesel gets combusted inside the engine, and the engine has to be cooled. So this is radiator, the coolant, and the coolant pump mechanism in a regular car or lorry, whatever it is. So this is braking system in regular car. The we call it as power brakes. There has to be a brake cylinder, brake distributor, disc brakes, drum brakes. All these brake lines have to be connected, and the brake distribution has to be done. This is mechanical setup in regular cars, and these are the parts: brake shoes, brake pads, brake drums. cylinders, valves, all these things. So many parts are there in this braking system. So this is suspension system. So a regular car needs lot of suspension parts, moving parts, uh, driving axles, so front wheel or rear wheel drive. So I hope so you understand all these things. Next, regular car needs transmission. So the power is generated in an engine. It has to be transmitted through a gearbox to the rear axle. So it needs an axles housing. So the power has to be transmitted to the tires, and the tire has to transmit the power to road to move the car forward. This is the regular setup. So this is a housing. There are hundreds of parts inside a housing. It's a pinion or crankshaft, sorry, the crown or the bearings or whatever it is. So the you can see it. This is called as a rear axle. You can see the very big rear axle in lorries, in SUVs like Scorpio or Safari. You can see these rear axles, but majority of the cars, modern cars, are front wheel drive. So this is four-wheel drive car. So engine is connected to rear wheel as well as front wheel. So only front wheel we call it as front wheel drive. Only rear wheel we call it as rear wheel drive. If it is driven by all wheels, we call it as AWD, all wheel drive, or generally 4x4. 4x4 means all four wheels are connected to engine. This is rear wheel drive axle. It has lot of parts. All these parts have to be manufactured by the lathe or lathe machine operators in a workshop. Okay, so you would have done the lathe workshop in first year workshop. Okay, so this is wiring kit for a car. This is how all the red lines are wires, cables connecting different parts, different sensors in a regular car. So much wiring is there in a regular car, IC engine car. So this is exhaust. The when petrol burns, flue gases comes, and all those flue gases must be sent out. Okay, this is exhaust system. All the blue lines are exhaust system. So many components are there. This is AC system. The passenger has to be comfortably seated in the cabin. So the cabin has to be cooled. The cabin space is where passenger and driver sits. So that space has to be kept cool. So this is the air conditioner for passengers. So the red line and blue line, these are the radiators, fans, propellers, all these things. So many parts are there in regular cars. Okay, so I hope you understand. This is a regular car, and regular car needs hundreds of parts, thousands of parts. Okay, I am showing briefly. Dear students, did you understood what I mean to say?
Yes,
This
sir.
is all about regular cars. Very good. Now I want you to unlearn to relearn. నేను మీకు ఇప్పుడు చెప్పిందంతా కూడా వదిలేయాలి మీరు. ఎందుకనంటే so we don't want to fail, because we have some old knowledge. This is the old knowledge. This is how AC works in a regular car. This is how flue gases comes from tailpipe. This is how wiring is done in regular cars. Okay, this is how rear axle is. This is how power is transmitted to wheels. This is how suspension is. This is how brakes are, brake distribution. This is how the engine is cooled. This is how gearbox looks like. This is how engine looks like, engine parts. So I want you to unlearn all this. Forget about all these things, because we are talking about electric vehicles. These things does not exist in EV. Only some of them exist. Many of them, they don't exist. So I don't want you to fail. Whatever I have taught you, you have to forget those things. If you want to relearn, you have to first unlearn. So I request all of you to unlearn, and then let's start relearning. Okay, I don't want you to fail in as an engineer in life. So, and I don't want you to fail as a startup if you start your business. So please unlearn whatever you have learned till now, and then relearn. So how to why this unlearning process is very important. This is a conventional car on the left side. This is a electric car on right side. Conventional car, I have already told you, it has engine, gearbox, transmission, axles, and the power is generated in the engine and transmitted to tire. This is conventional model, the left side. The right side is electric car. There is no engine, there is no gearbox, there is no clutch, there is no transmission. The motor is directly connected to tires. So this is the reason why I'm asking you to unlearn. Even if you see in bikes, there is chain, there is pocket, the power is generated in the engine, gear transmitted through gearbox through a chain drive. So forget about it, it is direct drive mechanism. So this is what is direct drive looks like in electric cars. The motor is in the wheel. This is a direct drive electric motor. You say where is the motor, where is the stator, where is the rotor, where is the rim, where is the tires in this? See, it is all integrated. I've told you this yellow color is motor. On the, let me take a pointer. Can you see it? See the difference between conventional car and electric car. In electric car, motor and tire are integrated. If you see, this is the cross-sectional view of a motor, direct drive motor in electric vehicle, electric car. Okay, so please understand, you have to, it doesn't look like, you're all electric students, you would have seen several motors. It doesn't look like a motor at all. There is no, you cannot identify where is the stator, where is the rotor, where is the shaft. So that is the beauty of electric vehicle. You have to unlearn, you have to think differently, you have to think disruptively. Okay, so tire, rim are part of the motor. So tire rim forms the rotor and the stator part is visible. I hope you can see. This is what I want to convey. So now let's get to hybrid vehicles. So people don't understand electric vehicles evolved from hybrid vehicles. Hybrid vehicles are, there are different types of hybrid vehicles. Mild hybrid, micro hybrid, hybrid, pure hybrid, parallel hybrid, series hybrid, plug-in electric vehicle hybrid, or simply hybrid vehicles, HEV. In majority of the cases, most of the vehicles, electric vehicles moving on the road are called as electric vehicles. Actually, they are not pure electric. Some of them are hybrid electric vehicles. So I want you to understand this. If you want to start a company which produces some kind of goods for electric vehicles, you must know the difference between HEV and EV, hybrid electric vehicle and electric vehicle. That is the reason why I have shown different types of hybrid vehicles here. So this is the setup of hybrid vehicles. In hybrid vehicle, you will have engine and motor, a petrol tank and battery, a power electronic converter. You will also have gearbox. I told you this is how a conventional look like and this is how an electric look like. But this is how an hybrid look like. A hybrid will have both engine, motor, gearbox, battery, power electronics. That is the reason why hybrid vehicles are very costly. People mistakenly assume that electric vehicles are costly because they don't buy electric vehicle, they buy hybrid vehicle by mistake. మళ్ళీ రాకూడదమ్మా, వెరిఫై చేస్తాను. ఇక్కడ ఉంచేసేసి మళ్ళీ వెరిఫై చేస్తాను. ఏ పీరియడ్ ఫ్రీగా ఉంటావు నువ్వు? ఫ్రీగా ఉన్నప్పుడు రమ్మొచ్చు, వెరిఫై చేస్తాను. అట్లా. సారీ ఫర్ ద ఇంటరప్షన్. So hybrid vehicle is costly because hybrid vehicle has a petrol tank or diesel tank, an engine, a transmission, gearbox, clutch, all of them. Additionally, they will have a motor, power electronic converter and battery. That is the reason why hybrid electric vehicles are in crores. Electric vehicles are in lakhs. Petrol vehicles are in few thousands. I'll show you that price variation also. So this is a simple way of understanding conventional, hybrid and pure electric. Okay. So the first classification is conventional. The first classification is conventional. Dear students, are you able to see the screen I am sharing?
Yes, sir.
Are you able to see what I am scribbling with a pointer?
Yes, sir.
Yeah. In conventional vehicles, that is petrol and diesel, you can start and stop and it runs on petrol or diesel. Okay. In mild hybrids, it runs on petrol and diesel, but when you apply brakes or when you are coasting, or when you are descending from a hill, కొండ మీద నుంచి కిందకి దిగుతున్నప్పుడు కానీ, బ్రేక్స్ అప్లై చేసినప్పుడు కానీ, లేకపోతే ఏదన్నా ముందు అడ్డం ఉందని చెప్పి స్లో అవుతున్నప్పుడు కానీ, mute yourself. We are getting noise. Mute yourself. Someone, thank you. So energy is recovered in hybrid, okay, during coasting or braking or descending from a hill. So mild hybrid, we call it as mild hybrid. In regular conventional vehicles, there is no such recovery. When you apply brakes, all that kinetic energy is lost. But in mild hybrid, when you apply brakes, some energy is recovered and stored in battery, and it is momentarily charged. It is not charged for eternal. It is not charged for 2 or 3 days. It is charged only for 2 or 3 seconds and gives back in 2 or 3 seconds. So it happens in less than 1 minute. Next is full hybrid vehicle. As I told you, full hybrid vehicles are very, very costly. They have an engine, they have a battery, and they have a motor, all those setup. Next, plug-in hybrid vehicles. When you are at home, you can charge your battery and you can start your journey. If the journey is very small, if you want to go to a small shop and buy some groceries, or if you want to go to nearest cinema hall and watch a movie, you can use the energy in the battery. You can charge it at home and you can take short rides. If you want to go on a long ride, you can use petrol or diesel stored in the tank. And these engines are suitable for charging the battery, at the same time propelling the motor. These are called as plug-in hybrids. They are also damn costly. I'll show you the difference. This is plug-in hybrids. These are also electric vehicles, for your kind information. Next, battery electric vehicle. This is what I am talking about. This is what one student inquired. Okay, battery electric vehicle is, the setup is same. It's an automobile. It has a motor. It has a battery. You can charge battery and you can use energy stored in the battery. Next, fuel cell electric vehicle. Fuel cell, you have to use hydrogen. You have to replenish. If hydrogen is over, you have to fill the tank with hydrogen. You cannot charge it at home. You have to fill fuel. Fuel is generally hydrogen. Example is Toyota Mirai. Recently, Nitin Gadkari used this car to come to Parliament. Okay, he launched H2O cars in India. Okay, it needs hydrogen. Instead of filling with petrol, you have to fill with hydrogen. And hydrogen is not available in nature directly. You have to manufacture hydrogen. So that is the limitation of hydrogen fuel cells. Dear students, are you able to follow what I am saying? Because it's a very elaborate topic, very detailed topic. Do you understand?
Yes, sir.
Do you understand what I am saying? Are you able to follow?
Yes, sir.
Very good. Shall I go ahead with my presentation? Because Naresh, time is 12:15. Can I continue with the presentation, or is there any time limitation? Dear audience, can I continue? Do you have any other lecture or lab session or whatever it is? Can I continue?
Continue, sir.
Okay, thank you. Is my lecture interesting? Because it's a very elaborate topic. I have to concise it and I have to present it for you, because you are all first year, second year guys. You don't know ABC of electric vehicles. I have to cover ABC of electric vehicles also. So let's see. Let's get back. Are you able to see the screen I am sharing?
Yes, sir.
Good. So now let's see comparison of hybrid vehicles. So how regular vehicles are different from hybrids, and how hybrids are different from battery vehicles, how battery vehicles are different from fuel cell vehicles. I have shown you in a very short glimpse. In similar manner, I would like to show you in terms of electric power. People have some misunderstanding or lack of understanding or lack of information. All these three cases are very dangerous. మిడిమిడి జ్ఞానం అంటారు తెలుగులో. ఇఫ్ యూ ఆర్ ఇఫ్ యూ హ్యావ్ half knowledge is very dangerous. So it is my duty as a teacher to give you some idea. So micro hybrid vehicles only have 2 to 5 kilowatts of power. Say for example, a car needs somewhere around 70 horsepower to 90 horsepower. When you convert horsepower into kilowatt, I think you know 1 horsepower is 728 kilowatts British horsepower, or 738 kilowatts, 738 watts. You
Hello,
can
Ravi
convert.
Prasad, sir.
Naresh, shall we continue?
Sir, your voice is not clear, sir.
Okay, am I audible now? Am I audible now? Is my voice clear now?
Yes, sir.
Okay.
Yes, sir, it is audible.
Okay. Shall I continue because time is 12:15? Am I messing up with your schedule? Shall I continue?
Yes, sir. You can continue. You can end up around at 12:35 like that, sir.
Sure. I'll speed it up because
Yeah.
we have to go. So I request audience to understand how much support is given by the electrical system to a regular engine. In micro hybrid, only 3 to 5% support. 3 to 5% support comes from motor. 5 to 10% comes from ISG hybrid. In mild hybrid, 20% support comes from batteries and motor. In full hybrid, the entire power required for propelling the car is generated by the motor, and motor gets power from the battery, whether it is fuel cell or electric lithium ion or lead acid battery, it doesn't matter. Okay, so I request all of you to understand how much support we are getting. Okay, so now let's see internal combustion engine and electric motor. If you want to understand if you want to see the opportunities, startup opportunities in electric vehicles, you have to understand how a regular geared petrol car is different from electric car. Okay, you can see both the graphs of on the left top corner. You can see both electric motor driven car and IC engine cars. You cannot keep the same amount of torque. With changing speed of the car, you have to change the gears. You can see the first gear, second gear, third gear, fourth gear. Whereas in electric car, you can see the torque is seamless and you can maintain the torque very well. Or if you are unable to understand in this diagram, you can see this. From up to some point, you can run the motor as constant torque motor. After that, you can run it as constant power. Okay, you can run it as variable power, constant power. Okay, this is the advantage of electric vehicle, which is not available in a regular petrol or diesel car. For getting this kind of constant torque and variable torque, or constant power and variable power features, you have to shift the gears. And you can see the torque and speed are not constant. Torque and power are not constant in all the gears. You have to run the engine at ideal speed, and you cannot run engine at ideal speed without increasing the speed of the car. It is not possible in traffic. So petrol vehicles give least mileage in town or city, and they give best mileage on highway, whereas electric car can give you highest mileage no matter whether it is highway or whether it is city or whether it is crowded or whether it is a stop gap traffic. Okay, so I hope you understand these are the speed torque curves of a regular petrol engine. This is the torque curve, this is the power curve. Okay, you can see the difference between the petrol cars and the motors. This is where you can identify so this is how the fuel efficiency drops in petrol car. This is where we have opportunity. See, when you travel at around 60% of the engine speed, maximum RPM, you get the highest mileage. fuel consumption. You can see fuel consumption is best. Okay, as you go, as your engine speed, percentage of maximum RPM increases, you can see percentage change in fuel consumption, liters per hours per, is almost all becomes zero. If you run your car at highest speed, it consumes fuel very quickly. Okay, percentage change in fuel consumption increases, so it consumes 100% of fuel at 100% RPM. Hope you understand. Okay, this is the advantage of electric motor. You can switch from forward motoring. I think if you are second year, third year student, or fourth year student, you will know what is forward motoring and forward braking. This is speed torque characteristics of a DC motor. This is speed, this is torque. Okay, this is negative torque. You can say this is minus T. Okay, speed is always positive, but torque is either positive or negative. So if your motor is operating in forward motoring, you can switch it to reverse motoring in this manner, and you can stop the car and once again start it from a slower speed. This is what is the path. This is not like your regular engine, IC engine. This is not like your regular brakes. This is called as electrical brakes. This is how we can switch from forward motoring to forward braking efficiently, effectively, without a short gap also. You can reduce the speed. Say for example, it is running at 100 kilometers at this point. You can immediately switch it to 10 kilometers in a short notice. You can bring it to here. From here to here, you can reduce the speed using this method. This is taught in PSD subject. This is how your motor operates. This is the speed torque characteristics of an induction motor. Okay, this is how speed control is done. Some of you may be familiar with speed control. Constant torque region, constant power region, breakdown torque. This is different speeds of electric motor, and electric motor is used for electric cars. So these are the potential areas where you can do startup. Your electrical knowledge is useful to design the motor, control the motor. I'll show you all those things. These are some of the important aspects on which comparison is made. These are the petrol or diesel cars. This is hybrid vehicles. This is electric vehicles. So petrol cars come, petrol or diesel car come from 7 lakhs to 1.1 crore. Whereas hybrid vehicle starts from 1.2 crores to 2 crores, 12 lakhs to 20 lakhs. Whereas electric vehicle comes from 9 lakhs to 60 lakhs. Okay, so hope you understand the difference between a petrol diesel car or hybrid vehicle or electric vehicle. Once again, in electric vehicle, we have fuel cell based also. So I'll share this presentation with Naresh. You can read it when you are free. So now there are a lot of advantages of electric vehicles. Low center of gravity, no coupling, no gearbox, no belts, no chains, no hysteresis, backlash, or lost motion in any direction of movement, no noise, no vibrations, zero emissions, low running cost, low maintenance cost. These are all advantages of electric vehicles. So the future belongs to electric vehicles. There is no doubt. So already mild hybrids are there in market, like Mahindra Scorpio and Maruti Ciaz. So many cars are there, battery assisted hybrid vehicles or power assist hybrid vehicles. Lot of vehicles are there on road. You can find it even in your college parking space. You go and find out one micro hybrid and try to discuss with the owner of that car. He will give you very good insight.
Sorry, Prasad, sir.
Okay. Yeah.
Yeah, already time is over.
Yes, last 2 minutes. Okay.
Okay,
So
okay, sir.
it's
Already
time
put in
to
the time around 12:30 only.
it's over. It's over. I'll wind it up quickly because
Okay, okay.
so dear students, dear participants, dear audience, I want you to do SWOT analysis. SWOT analysis is strengths, weakness, opportunities, and threats. I hope you have seen why, when, where, how, what all these things you have. I've shown you the difference between IC engines, hybrid cars, and electric cars. In electric cars, I have shown you all those things. So I want you to understand the opportunity. There is opportunity here to start business. I'll take you briefly. This is the main part of our seminar. Whatever we have studied till now, this is all the basics, because I don't know the level of the audience, so I have to tell you all these things. So hope you understand. You have reached somewhere around 67% as far as I'm concerned. I taught you somewhere around 60 to 65% from my point of view. I don't know how much you understood and how much is your knowledge level. This is what from this point onwards, it is self-driven. You have to find opportunities, you have to meet people, you have to interact with people, you have to explore. This 30% of the next journey is in your hands. You have to read well, learn well, understand the subject, read newspaper, listen to the news, talk to the expert, go to various showrooms, visit the electric cars, try to understand the technology behind it. So from this point onwards, it is in your hands. My job as a teacher is take you past the halfway is 50% crossed, so we are close to 60%. So now where are the opportunities? Charging infrastructure. We have to set up chargers on highway so that electric vehicles owners can charge their car by paying some amount. So this is opportunity number one. Okay. We have to supply chargers to such franchises. So at present, it needs 90 minutes to fully charge. So there is possibility to do marketing, manufacturing of chargers. Okay. So at present, there are around 90,000 petrol bunks in India. It takes 8 minutes to fill a car, collect the money and send the car out of the petrol pump. But electric car needs 90 minutes to charge. So if you get 100 cars, you need to have 100 chargers. In petrol pump, you will have only one pump, you can fill 100 cars. But electric chargers are different. If you get 100 cars, you need 100 charging outlets. Please understand. So that is the reason why there is a lot of opportunity for charging stations, chargers, charging cables, charging plug points. So I'll give you a brief example. So India needs somewhere around 10,000 charging stations per year in next coming years. So you can ask me, sir, Ravi Prasad sir, how you can say India needs 10,000 chargers? I'll give you an example. In I think Tesla is the most successful car company. Tesla has sold only 6,27,000 cars worldwide till now. You don't believe it. Okay, Tesla has only 31,498 charging points on highway in 3,500 charging stations. So this current year in India, only 2,31,000 bikes are sold and 17,000 cars are sold. Whereas petrol diesel cars, 20 lakh cars. So you can see the difference. So there is a lot of potential. You can manufacture plugs as an engineer. You can manufacture, this is the standard types of charging plugs used. These are not your regular plugs. You can go to any electric shop and buy. So there is huge demand for manufacturing these plugs. As an engineer, you can start a factory and manufacture these type of plugs. And next, electric cables are not like your regular household cables. So they are TUV certified cables. So I request, there is opportunity to start EV cable manufacturing. Electric vehicle charging cables are different. Their standards are different. Their insulation is different. Their operating voltage is different. We have AC and DC charging. So there is opportunity to start business. Next, so there is opportunity for making retrofitting kits for existing cars. Retrofitting is something that is not supplied by the company. So take an old car, fit it with retrofitting. So retrofitting is, this is a cylindrical battery. Electric battery needs cooling. So if you want to travel for longer journey, or take up a longer journey, or travel in hot conditions, you have to retrofit. Okay, you have to fit some extra cooling fans. So it's a new business in electric vehicles. So these are prismatic cells, or Even pouch cells, they also need cooling. So you have to do some kind of mechanism to cool the batteries. You can sell that mechanism as retrofitting. Retrofitting is addition to existing car. Okay, there is opportunity to sell conversion kits. You can convert existing cars into electric cars by retrofitting it with motor and battery. Remove the engine, fit a motor and battery. So you can also sell, you can make design conversion kit, make conversion kit and sell conversion kit to existing cars. Okay, this is GoGoa1.com. They are selling conversion kits. These kits can be used to convert your existing bike into electric bike. This is a very good business model. You can take example of GoGoa1.com. And even in Hyderabad, we have this conversion kit factory. They are converting existing petrol cars and diesel cars into electric cars. So next, trading. Electric vehicle needs lot of metals. There is possibility of moving into trading of metals, especially aluminum is very, very important ingredient. So whether it is repurpose, reuse, recycle or reclaim, now it is time to rethink. You can take old aluminum and convert it into ingots, and these ingots are used for making electric cars. So aluminum is the important metal because your electric vehicle has to be very light. So next is big is better. So this is a gigapress used by Tesla. Earlier, people used to think that car is manufactured by small panels. Now the thought process changed. Tesla introduced gigapress. They were able to remove 370 parts. Single piece of chassis is fabricated in this gigapress. This is a very big press. You can see the size of human beings compared to this size of this gigapress. So this is what I'm talking about, disruptive thought process. This is single molded aluminum chassis or platform of for Tesla cars. This is real. This is not graphics image. Okay, Bahubali Sigmagar, this is real. Okay, you can see engineer standing in front of a single piece floorboard. Okay, now fastest, fast cars, fast servicing, fast swapping. All these things are very important. I hope you all know F1 pit stop, how quick it is. Now people are talking about they don't have 90 minutes to charge the battery, but they have 9 minutes to swap the battery. Tesla is promising to bring in battery swapping. On the left side, this is discharged battery is replaced with charged battery on a platform. This is the promise given by Tesla, battery swapping. And battery swapping is already initiated in several densely populated tourist places. This is a battery swapping station in Tirupati. Okay, batteries can be pulled out and kept in this charger. So this is a battery swapping station. You can take battery from your auto and put it on charging, and you can take a fully charged battery and load it. It takes less than 9 minutes to swap the battery. So there is opportunity to start such business, battery swapping business. Okay, you can start battery franchise, battery charging franchise also. This is an example. Tata is offering battery franchise. You can take it up as a business. If you have a shop, just install a battery charger outside the shop. You will and update it in Google Maps and the electric charging infrastructure app provided by National Highway Authority of India and Bharat electric vehicle policy. Automatically people whoever are in need, they'll come and get their vehicle charged. Okay, so electric vehicle tires are also different from regular tires. So you can start tire manufacturing because it is disruptive. They are not like your regular car tires. Electric vehicle tires are a little bit different. I don't say they are completely different. So next, cabin cooling. Already I told you all cars are air conditioner, but electric cars air conditioning is different. It is based on Peltier effect. This is a sample animation of Peltier effect. Okay, hot on one side, cool on the other side. So I hope you know Toyota Innova has 3-row cooling. So front row passengers have different air ducts, center row passengers have different air ducts, and rear seat passengers have different air ducts. So disruptive thought process is you cannot have a single AC and pump air through to all the three rows of seat. Now you can use this Peltier effect and produce cooling locally. If the car is very big, you can have 3 or 4 air conditioners in the same car. You can turn on only one depending upon the requirement. Okay, so that's all for today. Sorry for jumping the line. Sorry for taking a lot of time. I'm done. Sorry for
So
the
audience, no,
delay.
no, sir, no, sir.
This is a very elaborate topic. This is it has to be dealt detailedly. If I give you simple knowledge, it will not be effective. So I have to take that extra pain to drag the presentation for another half an hour. Sorry for the trouble.
So audience, any questions, students? If you have any questions, please ask. Sir is here.
Time is 12:40. I hope students don't have any questions. Let's see chat messages.
And one more important, I have shared the feedback link in chat box. Just go through it and give the feedback of this lecture. So thank you, sir. Thank you so much. You are giving a lot
Let's,
of.
dear audience, do you have any suggestions or feedbacks or any queries? Do you have any suggestions, queries, or feedback? Did you understood what I detailedly explained you? Someone unmute from the audience side. Did you understood? Very good. Good. Okay, my intention is to educate you. My intention is to show you several avenues. There is lot of scope. There is lot of possibility. That's not my intention and the seminar organizer's intention. Hope you understood it. Thank you. Thank you very much for listening patiently. And today internet power, everything supported, so I was able to complete my lecture in 1 hour 40 minutes. Generally there definitely one power interruption or one Wi-Fi failure or one disturbance will be there. Today there is no such disturbance. I am very thankful
Sir,
to
when students are asking the question, sir, actually why using belt drive, not chain drive?
yeah, Naresh,
Chat box.
chain drive and belt drive, two issues are there. Slack, we call slack. Chain slack is always there. Since it is mechanical part, it is noisy. Belt drive, there is no noise. Belt is generally made up of rubber with nylon and steel reinforcing. So there is always danger that chain snaps. Chain has links which are very rigid, and uh, it goes and piles up in the sprocket area, and it may lead to sudden abrupt brake application. Engine braking possibility is there, and the passenger will be toppled. You can see a lot of YouTube videos. If belt snaps, there is no problem. If chain snaps, there will be huge danger that the person will be toppled. And the slack, because rubber is having some elasticity property, metal is not having elasticity property. Many when the swing arm, the rear swing arm in bikes, if it moves, the rubber belt will get automatically expanded and it gets compressed when when there is shock absorber movement. But in chain drive, if there is shock absorber movement, there is possibility that the chain may stop, the chain may come out of the sprocket, and lot of difficulties are there. So I hope you understood that. Then how can the US country, they're running EV Tesla cars with about charging stations in USA? Yes, very good question. USA is having only 31,000 charging stations, but they are kept at a very good intervals, and Tesla range is around 680 kilometers or so. There is one charging station between every 800 kilometers or so. That is, for time being, that is sufficient. Okay, You only need one charging station for the entire range. Say, for example, if range is 800, you have to have one charging station at every 800 kilometers. For time being, it is sufficient.
Thank you, sir.
Okay, okay. Thank you. I have other meetings to attend. I'm available on Facebook and other social media platforms. If you have any doubt, I'll be happy to answer your doubts. Okay. Thank you. Thank you very much. Have
Okay.
a nice day.
Thank you, sir. Thank you so much. You are giving
Please
nice
give your
presentation, sir.
valuable feedback.
Lot of knowledge you have shared, sir.
Yeah,
Okay,
I
sir.
have
Okay.
limited my
Thank you, sir.
presentation. I have limited my presentation. If time permits, I'll share more information on a very specific topic. This is a very broad topic. Startup opportunities in EV car is, I have to tell the entire industry story. That is not possible in 1 hour. I was able to squeeze a lot of information in this presentation. If time permits, if there is any particular occasion where I can speak on a particular technological issue, I'll be very happy. This is a very broad issue. I hope I was able to justify this 1 hour 40 minutes. Thank you. Thank you very much. Okay. Have a nice day.
Okay.
And
Thank you.
best of luck.
Thank you, sir.